Hello, this is Christine G, and I am going to be going over this problem in StatCrunch. Let's take a look. We have that this is about muzzle velocity of the shells fired from this 155 millimeter gun, and for each shell that they are taking two measurements on velocity and using two different measuring devices. So it's just one shot, and they measure it with something for A and then something different for B. But it's just the same shot. It's not like they're firing at two different times or anything like that. So why are these matched pairs data? Well, the first observation and the second one are dependent on each other. So the two measurements are taken on the same round. So measurement for observation A affects what the measurement for observation B is going to be. So let's go ahead and check that answer. Okay, so two measurements are taken on the same round. That looks good. Then we go on to the next part. Okay, so they're asking if there's a difference in the measurements between device A and device B at the alpha level of 0.01. So here, right away, I'm going to go into StatCrunch, and it is a matched pairs. So I'm going to go, oops, I forgot. I need to click into StatCrunch through this little box, because then it'll bring up all the data set. And then I go into T-statistic, and it's paired. And then here, for sample 1, it's not observation, it's the column A. And then for sample 2, it's column B. Observation is just a number that doesn't have to do with the measurement. So what okay, and then here, hypothesis test. So this just says that when we subtract the two, population means that they are equal to 0. And then, so that means that there's no difference between them. And the alternative is that when we subtract them, they don't equal 0. So they aren't different. I mean, they are different. So let's go ahead and compute that. So here we have 0.249 as our p-value. And it had said 0.01 is the level of significance. So let me go ahead and try and explain this a little bit. So we have our distribution. Let me go ahead and get the pen. And then here in the middle is the main difference. And then here what we have, we're looking at the rejection area way down in the tail, and it's 0.01. Now the p-value is bigger than that, so it's not way down in this area, it's outside of that. So let's say the p-value is 0.249. So it is closer to the middle. It's not way out in the tail to reject. So here we would not reject. Do not reject the null. Perfect. And then let's see. Okay, a 99% confidence interval with about the population mean difference. So let's take a look at that. So I like to just go in here and click edit, and instead of doing the hypothesis test, we're going to do the confidence interval at 0.99%, compute it, and then here we've got our lower limit, and our upper limit. So we just type these in. Oops. I need to be able to see it. Okay, so, and it's 3 decimal places, so negative 7.911. Oh, it's not typing for me. Sorry about that. Okay, negative 7.911. Okay, that worked. And then the upper limit is 4.044. Okay, and then we continue. Okay, so choose the statement that best agrees with the interpretation of the results. So I am 12% no. I am 1% no. I am 99% confident that the mean difference in measurement lies in the interval found above. That is what we're all about. Okay. Well, I hope this makes sense, and let me know if you have any further questions. Thanks so much for watching.